All right, a quick little video on 8.7. I realized I said I would put a video together and then completely forgot about it. So hopefully this, for those that need to see this, this is helpful, but I'm going to try and be as quick and concise as possible. So just a reminder here that when we are working with a function to the second power, so like x squared would be y equals x squared would be like the parent function or the most simple form of that. It creates a parabola. It's going to create this kind of U shape. And if it's a positive x squared, it's going to create an upward U shape. And if it is a negative, it's going to flip that around and create a concave down. So some important parts here when we're making parabolas. We have our axis of symmetry, and that cuts down through the parabola, and then any points reflect across that. So this point here reflects, I count one there, and then one more away, and I have another point. Same thing here, I can go 1, 2, and then I go 1, 2. So anywhere where we have points are going to reflect. The actual switch point here is called the vertex. And then we have our x-intercepts. So when we were solving for like x squared plus 3x plus 2 equals 0, and we would solve this out and get like x plus 2 times x plus 1 equals 0, and then x equals negative 2 and negative 1. That negative 2 and negative 1 were the zeros for our parabola. I guess it would have gone this way. Would be the zeros for our parabola, also called the solutions. So we said when our y value is 0, what is our x values? That's why we get it to equal 0. So when y is 0, what is x? When x is 0, what is y? That's our y-intercept. So in this case, our y-intercept is negative 1, 2, 3. Negative 3 there. So those are the important parts of a parabola, and we are going to be working with what's called vertex form. So vertex form looks like this. It is a, we're going to have our x to the second power, and then we have some stuff going on inside and outside. So I'm going to describe the transformation of each quadratic that's written here in vertex form. I'm just going to do a couple of them. And I'll try to color coordinate these. So the first thing we look for is we look inside the parentheses. And this is telling us this negative 2 actually means that we're moving right 2. So our first transformation that we're going to list is that from our parent graph. So if we had y equals x squared, this is just our general parent graph, that that this would move right 2. So here's our original, and that negative 2 is telling us this actually shifts right 2. So that's the first transformation. The second transformation we'll list is this negative, and this negative is telling us that our whole parabola is going to flip over. It's really called an x-axis reflection. But to simplify that, it's a flip. It flips the whole thing over. The third thing we'll describe is this 2 out front, and this is a vertical stretch. So this is going to stretch our parabola out by 2. And so essentially what we're doing is all of our y values for each point gets multiplied by 2. So our parent y values. And then the fourth thing we'll describe is that our whole parabola is going to shift down 2. I'll just say down 2 here. So the whole thing is shifting down 2. Okay, and so those are the 4 transformations that we would see listed here in what we call vertex form. The vertex form, we're able to tell what the vertex is. This is called H and K, and it's the opposite. So our vertex here would be +2, -2, and those are coming from here and here. So here's my +2 that I got and my -2 that I got. And so on my graph at +2, -2, which would be down here, and then flipped over. So that would be my quadratic there. So let's look at a couple more of these. So again, it's kind of important to understand that this is shifting because we're going to make these, so this one, whatever's inside here, only applies to the x. So this is going to be a right shift of 1. Everything outside of our parentheses happens to our y value. So in here we have a vertical stretch, so that happens to our y value. By 2. And then the whole thing moves up 4, and that's happening to our y value. So those are the transformations that are taking place. Here we have a +3, so remember we do the opposite. So our first thing, we're going to move left 3. Then I'm looking out front. And that is telling us we are going to stretch by 2. And then the last thing is that this whole thing's moving up 4. So the first step happens to our x values. The second, third, and sometimes fourth, depending on if we have a negative or whatever, everything else happens to our y values. So let's take that information, and in the guided practice, you would have tables here. So we've been given in vertex form, and you'll see there's a table here. This table is in all of our examples, and I'm not going to do all of these, but what that means is this is our parent function. So think about just kind of your basic, like if we just had y equals x squared. This is what we would get out. If I plugged in a -2, if I square it, I'll get out a 4. If I plug in a -1 squared, I'll get 1. 0 squared is 0, 1 squared is 1, 2 squared is 4. So this is our, what we call parent function. And now we are going to mathematically change our parent function values based on the transformations that were given to us up here, which is why it was important we kind of understand what's going on here. So the transformation, our x value is going to move right 2. So I'm going to add 2 to my x here. And I got that, I'll highlight in red, from here. My y values are going to stretch by 2, so I'm going to multiply a 2 down here. And it's shifting up 1, so I'm going to add a 1 here. So each of these is a point. -2, 4, that would be a point on the graph. -1, 1, 0, 0, 1, 1, 2, 4. Those are points. So I'm going to section this off so it's a little bit easier to see. But I'm going to take my x value from my point, so -2, and my y value from my point, 4. I'm going to plug them in here and here. So I'm going to have, I'll do that in blue, -2, and this y is going to be a 4. So I've taken that from here and here, and then I'm applying the transformations. And then I can work that out. So this is 0, and then 2 times 4 is 8, plus 1 is 9. I'm going to do that for each point. So all of these are going to be added by 2, and everything on my y is going to be multiplied by 2 and then adding 1. So it's going to be multiplied with 2 and then add 1, multiplied with 2 and then add 1, I need one more, multiplied with 2 and then add 1. So I'm going to use negative 1 and 1. I'm going to use 0 and 0, 1 and 4. I'm sorry, positive 1 and 1, and then 2 and 4. And each of those came from here. Okay, and then I'm just working each one out. So this is going to make 1, 2, 3, 4. This will make 3. This will make 1. This will make 3. And this will make 9. And then once I've worked those out, each set becomes an ordered pair. So this is 0, 9. This is 1, 3. I'm getting them from here and here. 0, 9, 1, 3. So 2, 1. I have 1, 3 and 2, 9. And then if I were to graph those, 0, 9, 1, 3, 2, 1. Oh, sorry, I said 1, 3. It should be 3, 3 here. I was working so quickly. 3, 3. And then 4, 9. Trying to get through this quickly. So 3, 3, 4, 9. And there's our parabola. So instead of doing another example, if you need to see that, go back and watch it again and how the setup happens. But we're going to use these numbers every time, and then you're setting up a table based on the information you have up here.